Welcome to CCT PID Tuning Reset video. We will look at literature locations. For example, in the product literature internal site of the portal, look for the system release level link, as well as in Quicklette under Metasys, Software, Tools, Controller Configuration Tool. This is where you will find the help file in PDF format for all detailed information, which is actually the same as found on the online help. The objectives of this video are what is modified by the PID reset feature, examples of when to use this function, how to perform a reset of the PID tuning parameters, and how to trigger the tuning reset procedure. Let's now take a look at the PID tuning reset function. I have CCT open with a standard fan coil application. Over on the left side is the tuning reset network input point, and this point is connected to the module known as PID tuning reset, which is one of our state generators. Let's take a look at that connection. In the connection menu for the PID tuning reset state generator, you can see that the input is coming from the tuning reset network input point, and its outputs are going to the proportional cooling control module, as well as the heating control module. And the second output, which is the state output, is actually going to the state table. So we can see from this that there are two modules that are receiving the PID tuning reset output from the state generator. Let's now take a look at an example of when the tuning reset would be implemented. Here is a slide that shows various applications of when the tuning reset could be applied. An example here would be if the chilled water to the air handler, which the FEC is controlling, if there is no chilled water, then the FEC will not tune properly. Other examples of when tuning reset would be used is if your valves are not working properly, or if the water circuit is unbalanced, or if there is uncontrolled water flow or temperature. After all these problems have been solved, use tuning reset to restore the original PID parameters so the PID can regain control quickly. Here's a drawing that explains the state generator for the PID tuning reset. Inside this logic diagram, you can see that there's a block known as the PID tuning reset finite state machine. This block here will output a normal or a series of 4 state commands known as reset 1 PID, reset 2 PID, reset 3, and reset 4 PID commands. So there are 4 commands that are cycled through. Each of these commands lasts 5 seconds. There is also a mux block where when the input is normal, a false will be coming out going to the state table. If the input is one of the 4 reset PID inputs, then the output of the mux block is true going to the state table. The other output coming directly from the PID tuning reset finite state machine block goes to the PID tuning reset connector, which is also connected then to the output control logic modules that have the PID block. So let's take a look at how this looks in CCT. We're now back at CCT with the standard fan coil application, and we're going to look at the logic for the PID tuning reset state generator. So this is the logic for the PID tuning reset state generator module, and you can see that the input connector, there's a last value block, And then there's the PID tuning reset finite state machine block, which mentioned earlier that this outputs either a normal or one of 4 commands. Here's the mux block, which outputs either a true or false, depending on whether we're doing self-tuning. Since the PID tuning reset connector here goes to our modules, we'll take a look at that. But first, let's look at the connection to the state table. So I'll view the state table. And if we locate the state generator that's known as PID tuning reset, we can see that it has either a false state, which means we're not doing tuning reset, and you can see there's an asterisk next to our output control modules, which means nothing will happen because of this state. If it goes true, then a hold state is sent to the cooling control. A hold is also sent to the heating control. And if we look at the other modules, nothing is being sent to the single speed fan control module. So it's just the modules that actually have a PID block that go into the hold state during the reset procedure. So we'll be looking at that in more detail. So now let's look at the proportional cooling control logic. And we'll view its logic view. I'll make a little more room here. I'll hit Fit to Window. I'll select it again to display the logic. And you can see here that on the lower left-hand corner is the PID tuning reset connector, as well as this command hierarchy block, which actually sends an output to the hybrid block called cooling out state. Well, let's look at this hierarchy block a little more closely. Here's the hierarchy command block for this cooling out state logic. And we can see that when it goes hold from the mode connector, which comes from the state table, and the connection is one of the reset commands, then the logic that's actually going to be executed is the control mode. It's during this control mode that the PID inside this logic module will actually perform the reset function. And keep in mind that this command here only lasts 5 seconds as it cycles through the reset second PID, reset third PID, and reset fourth PID. This module is not affected by those 3. Only the first one, since there's only one PID in this logic module. Later I'll show you a CAF file where they use all 4 of the reset commands. Now let's look at the control layer. I'll zoom into the PID area. And here is the PID tuning reset connection coming into a enum to Boolean block. And we look at that. If it's normal, a false is going to come out, which means we're not doing any tuning. If it's not normal, which means one of the 4 PID reset commands are being executed, then it's true. And this true signal is connected to the reset tuning connector of the PID block. Therefore, this PID will go into a reset tuning state only for that transition of 5 seconds for this one PID block. Now let's go and take a look at a timing diagram of how this is all put together. Here's a timing diagram that shows the sequence of events. This is the network input point called tuning reset. When that goes true at this time period right here, that's when the state generator, known as PID tuning reset, will actually go through its sequence of sending out the 2 outputs. One of the outputs goes to the state table, and it is going to remain true for 20 seconds. The reason 20 seconds is there is because the other outputs go through the 4 reset commands. Reset first PID, which lasts 5 seconds, reset second PID, reset third PID, and reset fourth PID, and then it goes false. Also notice that this command here from true to false can be performed at any time because it has no impact on the tuning procedure. It's only when it goes true, from false to true, does it invoke the state generator commands, sending it to the state table as well as to the PID modules. Now inside the state table, there's an asterisk first, which means it's sending out no commands to that module. Then it sends a hold command out. And this hold command goes to the mode connector of those output control modules. And as you can see, it lasts for the duration of the 4 reset commands, each one being 5 seconds. Therefore, it's a total of a 20-second hold command to the output control modules. Now in the fan coil application that we were just looking at, for the proportional cooling and proportional heating modules, each one containing 1 PID, you can see on the first one here, if the cooling proportional control module is currently in control, the first reset PID command puts it into the control mode, but it already was in control, so it stays in control mode. And then for the second reset PID command, it goes to the hold state, and it just remains there for the remaining 15 seconds before it goes back to control. So it's this first command that actually resets the PID for the cooling out state. If we look at the heating out state, if it's currently in the off mode because cooling is in control, therefore heating is off, it'll still go into the control mode during that first command so that the PID can reset its attributes. And then it goes into hold for the remaining 15 seconds. And then it goes back to what it was normally, which was off. Let's now go to CCT and go into commissioning mode and see this operation in real time. All right, we're back in CCT, and I'm going to go into commissioning mode. I'm now in CCT in commissioning mode for the standard fan coil application, and we can see that the proportional cooling is in control mode and proportional heating is in the off mode. So let's look at the logic for proportional cooling. Here's the logic for proportional cooling. Here's the PID tuning reset connector. And let's take a look at the command hierarchy block right now. And we'll see that it is currently in control mode. And the state is in control. Therefore, the PID is actually doing its function. And here's the PID layer. Here's the enum to Boolean translation block. Let's take a look at that. And we can see we're currently in the normal input, which gives me a false output to the PID block. So the PID is not being reset at this point in time. If we look at the PID details, I'll show you which of the attributes are actually reset back to their initial values. So let me expand this. The attributes that the PID reset will affect are the effective proportional band and effective integral time. Those are the 2 attributes. Currently, my 2 values are actually the initial values for this PID self-tuning algorithm. So these are the 2 attributes that would get reset when the reset command is sent. What I'm going to do now is actually go to, I'll go back to the application view. And I'm going to execute this, but I'm going to do it from the user interface. So let me arrange CCT. Over here in the user interface, I have my NAE and I have my 2 controllers. I have an FEC and a VMA. And in the top left display area is my VMA with all the points that I've mapped in. And on the right side on the top is the FEC, which I've mapped in. Now you may have also noticed that I've mapped in the tuning reset point for both of these controllers so that we can see what happens when I command it to true. Also, you'll notice that I've also mapped in the heating out and the supply air damper out, as well as the cooling out state and the heating out state for my FEC. And if you recall a few minutes ago, the cooling out state is in control and the heating out state is off for the FEC controller. So now I'm going to command both of these tuning reset points for both of my controllers. But in order to do that, one of the methods is actually using a tailored summary. So I have one already pre-built, and it's going to bring in my two controllers, and I've mapped into the point the tuning reset command. And if you notice, I have also in text here, command true, then false, because I know that the state of going from false to true is what actually executes the tuning reset procedure. When it goes from true to false, that has no impact. So what I might recommend is when you command this to true, you might as well just turn it right around and command it to false, a few seconds later, because it has no impact on it. Being a tailored summary, I get to highlight the two commands from my two controllers. These are the tuning reset points that I've highlighted. And if I right click and do a command, I can then invoke the global command so that both of these controllers will be reset at the same time. Now when I click on the send button, I'd like you to look at the tuning reset command here, as well as the two states of cooling and heating. Now keep in mind that the display refresh rate for the user interface and CCT is about 20 seconds. Since the tuning command going through its 4 commands, each being 5 seconds long, you'll see a total of 20 seconds that it takes. So it may or may not give me a good example here because of the refresh of the user interface. But we'll see what happens. So I'll click the send button. There's my report. And you can see both cooling and heating went to the control mode. Then they went back to hold for the remaining duration of the commands. And when they're done, you can see now that the cooling out state went back to control and heating out state went to off, which indicates that the tuning procedure has actually occurred. And the same actually happened over in the VMA. I just did not point that out. Also, you'll notice that my tuning reset command is still true for this tuning reset point. So I should come back, highlight these two again, do another command, and make them false. That way I'm all set in case I need to send this command again in the future. Now what I'm going to do is bring CCT back up. And what we're going to do now is I'm going to execute the same command from the user interface, but this time we're going to watch the tuning reset command going true because it's mapped to the NAE and I'm commanding it from the user interface. We'll also see this going true for 20 seconds. And we should see the values of the proportional cooling and heating also go into that hold state, the control state, and then back to normal. So I'm going to go back to the user interface here, select my two outputs, or select the two controllers that have the tuning reset, and I'm going to select true. Now I'm going to hit the send button and then go into CCT and display it. All right, so tuning reset should be going true here since I'm in the commissioning mode. And you can also see then that the PID tuning reset went true and proportional cooling and heating are in hold state. Now keep in mind that the display refreshes every 20 seconds, so we may not see exactly what's happening in the controller. There we go. And now I'm finished. Cooling control went back to control, heating went back to off. The state generator went to off or it went to false. But if you notice, my tuning reset network input point is still true because that's the one that's mapped to the NAE. So I can go back to my NAE here and send the command to false so that I'm prepared again to do this if I need to again. So in CCT, my tuning reset network input point right here should be going false, and it just did. So what I'm going to do now is actually perform the command again from the user interface, but this time I'm going to go into the cooling control logic and visually see the reset procedure actually taking place. So I'm going to come back here, send another true command, go to CCT, go into the logic view, and here we are. I'll double click the hierarchy so that we can see what's happening right now. It went into the hold state. I may have missed the reset first PID command. And it looks like I'm back in control already. So I could not see that because of the display being 20 seconds and updating. The command actually executed. But you can see what's going to happen here. When the reset first PID command is executed, this module goes into the control mode during the reset procedure, and then it goes back to the normal mode, which was control. If we look at the heating out logic, and we look at its command hierarchy, this one is off right now. But what it would have happened is when it was a mode of hold and the first command, it went into the control state during its reset procedure, and then when it's all done, it goes back to the original state, which was off. So I think in this example I'm going to do now is I'm going to get CCT set up with a closer view here so that we can see the actual command from the command hierarchy block executing. So I'll leave CCT in that zoom mode. I'll go back to the user interface again. Let's see, I need to command these to false and then to true. So let me send the false command out. And then I'll send another true command to demonstrate how this looks inside heating logic. Keep in mind, currently it's in the off state. So we should see now the PID tuning connector for command hierarchy go to hold and then reset first PID. You can see the output is in control. That means the PID inside this control layer is being reset, and when this command is finished and it cycles through the second, there's the fourth one that shows up, it stays in the hold until my reset commands are completed, and then it'll go back to normal, which then puts me back in the off state. So that's just what occurred right now. So let's go back to the user interface, and I'll explain other ways of commanding this point called tuning reset. First of all, I'll put this back to the false state again. Because if you notice, I've been using tailored summaries to command the point. Well, I guess another method would be maybe it's just one controller that you're concerned with. So you could command that tuning reset point manually, one at a time, or you could use tailored summaries to gather multiple tuning reset network input points from multiple controllers. That's what I did with this example. I could have also done a global search, so let's demonstrate that. I'll add the NAE to my global search, and the object I'm looking for will start with tuning, and I'll click on the search button. Now I only have 2 tuning reset network input points that are mapped to this NAE, but being a global search, I can find what I'm looking for. I could highlight both of them and right click and select the command, which sends a global command again and I could send it true, which would then reset the PIDs for these controllers. Another method would be if this point is mapped to an NAE, you could also use Mass Edit Live as one of your options for commanding various tuning reset points. If this command is not mapped in, then what you could do is bring over this field bus and go to the Engineering tab. So this would be an option if the tuning reset point is not mapped to the NAE, you could still command it from the Engineering tab. So I'm looking at the FEC controller. My system name is called Standard Fan Coil, so I'll expand that, because under that system name is the tuning reset point. Now I still have it mapped, that's why there's this blue check mark, because it's still mapped into this NAE. But if it wasn't mapped in, that blue check mark would not be there. I could double click on it to bring it over into the details window on the right side. I could select the edit button then, find the present value, which is right here, and I could send it to a true. And when I click the save button, it actually sends a value of true now to that tuning reset point for that device. And then when I'm done sending the true command, I would come back and change the present value back to false. So we looked at a method of commanding the point if it's not mapped. Another method would be using the NAE point schedule, where you would put the tuning reset point in the parameters tab of a template, and then you could use the write command to send that value out to those controllers. All right, now let's take a look at an application that uses 4 PIDs inside one of the output control modules. And the application that I'm going to be opening up is a mixed air single path face and bypass application. So let me open that up. So now that I have the face and bypass application open, I'll maximize CCT. And in here, I'll scroll down the network input points, because that's where the tuning reset network input point is. Here's the state generator, known as PID tuning reset. If I look at that connection menu, we can see that the 2 outputs, which is the PID tuning reset and the state output, those are the same 2 outputs, but notice there are 5 modules that receive PID tuning reset commands. Also, it goes to the state selection table. So let's take a look at the state selection table first. And here towards, I have it here now. Here's the PID tuning reset state generator. And when it's true, we can now identify which modules are going to receive that hold command. And there should be 5 of them, because that's what the connections were. So as we scroll to the right, there's 3 or 4, and there's the 5th one. So let's take a look at one of these, which is the face and bypass proportional valve module. And if we look at the details of this one, let's see, let me zoom in a little better here. We can see towards the bottom left-hand corner is the PID tuning reset input connection. And with its line exposed, we can find out which of the command hierarchy blocks, because there's 2 of them at this layer here. And this one here is where it's connected. So I'll double click on this. And we can see now that the 4 reset commands are going to 4 different layers of this proportional module. So there's temperature control for the valve and the damper, and then there's a low limit control for the valve and the damper. So there are 4 layers in this module, each one having a PID, and since there are 4 of them, we will cycle through them with the reset first PID, second PID, third PID, and fourth PID commands. So we'll just take a look at one of them. Here's the temperature control valve. And if I scroll down, let's see a little bit more. Here's the PID tuning reset connection going into the enum to boolean, which is exactly the same as it was before. It's either normal or not normal. And in this case, we're going to be connecting to the PID block. And there's the reset tuning connector for the PID. So when that goes true, we will be tuning this PID block. Now let's look at a slide here, PowerPoint slide, that shows a diagram, the timing diagram now for this phase and bypass preheat control. And if we study this closely here, we can see that the reset PID command was for the temperature control for the valve. The second reset PID went to the temperature control for the damper. The third went to the low limit temperature control for the valve. And the fourth one went to the layer known as low limit temperature control for the damper. So this timing diagram explains and describes the phase and bypass valve preheat control module. Okay, now let's take a look at our objectives and answer some of those questions that were in the objectives. For example, what is modified by the PID tuning reset feature? Well, there are two attributes, effective proportional band, effective integral time. These are the attributes that will go back to their initial values based on the values by the PID preprocessor. I also showed you when the tuning reset feature could be implemented, and also how it performs the reset procedure by going out to these control modules and putting them into the control mode just for those few seconds while the PID block is resetting its two attributes. And then how to trigger the tuning reset. If it's a map point, you can use the manual commands, tailored summaries, global search, or even mass edit live. If it's not mapped to the NAE, you still could use the engineering tab or use the NAE point schedule.